when you are in Clever and you have chosen the Red McGraw-Hill app, instead of choosing Alex, I want you to click on this reveal math. And I'm going to walk you through finding an activity today.
Bro, wait. I can't find that.
Hey, we have fire drill and stuff. You have to be skedaddling in there.
So once you've hit the Red McGraw-Hill app, you're going to choose reveal instead of Alex. So choose reveal. And then at this point, we're going to choose the section we're on. We are going to Red McGraw-Hill app.
Oh yeah, I forgot about that.
And then instead of choosing Alex, choose the reveal. And then in module 1, click that little arrow next to it. Do you see table of contents at the very top? Click that. Right next to module 1, click the little arrow next to it. We're going to look at lesson 2. So table of contents, module 1, lesson 2, click that. Whoa. Okay, got it. Michaela's watching story time. All right, so at the top you have this table of contents. You're going to choose, it looks like this. Next to module 1, you're going to click on this arrow here. Then you're going to choose lesson 2. Now, where it says explore and develop, this second one down here. So you went to table of contents. You chose the arrow next to module 1. Then you chose lesson 2. Next, we're going to click this little arrow to expand, explore, and develop. And we're going to explore this very first thing here. Do you have that there? Yes? All right, this is what we're going to click on right here. This explore product of powers. We're going to look at this. Go ahead and click on it.
I'm lost.
You're going way too fast for us.
I've gone over it 3 times, but I will do it again.
Yeah, but my phone was
Wait, are we supposed to be on Minecraft, Lucas?
no, we're supposed to be on. Oh, it's on burrito craft or.
What is going on? So, yeah, go ahead. So you've chosen reveal.
Reveal.
Table of contents. Next to module 1, there's an arrow.
Arrow.
Click on the arrow. Choose lesson 2.
Lesson 2.
Now, you should see this explore and develop.
Explore and develop.
Click on that arrow to expand it.
Alright.
Then we're going to click on this top one, explore product of powers. Fair?
Yeah.
All right. So go ahead and click that. All right. So how can we simplify a product of powers with like bases? So we're going to use this web sketchpad. See these arrows at the top? We're going to go through 6 of them. It says 1 of 6. This is 1 of 6. Now this is what we're going to play around with. Ooh. We're going to play around with these things. It says, press the show set 1 button. I think mine has already been pressed. Show set 1. So if we want x times x to the 4th, it's even with what? Do you see these 2 bars here?
Yes.
It says drag point X so that it does not equal 1. So if x equals 1, these are all staying the same. We want it so that they don't equal 1. What do you notice about the lengths of these bars? Do the two new bars match any existing bars? What one do these two match? What does x times x to the 4th and x squared times x to the 3rd match? Gentlemen, get off of your game and follow along with us. Good luck getting here, because I've gone over it at least 4 times. So I hope you have paid attention somewhat and can get here. Go to reveal. Go to table of contents. Choose the arrow next to module 1. Choose lesson 2. Open the Explorer. Choose product of powers. Yeah. Sometimes. I don't always play it. All right. So here's the thing that I want you to do. Play along with this a little bit. You can move this X back and forth. But listen, what do these match up with? What is X to, it doesn't match up with anything? It lines up with this one. What is this one right here? X to the 5th. How do you think they got X to the 5th from X times X to the 4th? Good, because this X is really 1, and then 4 more is a total of how many factors of X? 5. If I have 2 factors of X times 3 more factors, I have a total of 5. Need help with that? Yeah, because you pulled it too far. Pull it back a little bit. If you pull too far this way, you're gonna lose all your things. Did you shove it off to the side? Uh-oh. Sorry. All right. So let's keep looking here. See these arrows here? It says point X can be dragged to the right and left. The numbers across the top of the sketch represent the value of X. All right, they're vertically aligned. So if the bars and expressions go off the page, it means the value is larger than 15. It says to see the ends of all the bars, move the orange point back to the left. So if you've lost the orange point, I don't know what to tell you. All right, so see these arrows at the top here? We're on 2 of 6 right now. We're going to change to 3 of 6. Here are 3 new bars on the bottom. If you don't have those bars, you might have to click on Show Set 2. It'd be right at the top where it either says hide set 2 or show set 2. We want it to say hide set 2 because we want to see these 3 bars at the bottom. So drag point X so that it doesn't equal 1. So if it equals 1 or less than 1, it's a little bit different. But if we drag it out here, what do we notice? What do these things equal? They equal what, Elizabeth?
Well, I accidentally did. I put my point in on it. I put it too far.
You lose yourself?
It's like stuck there. Like it's stuck.
Uh-oh. I don't know how to help you there. You might just have to look on and look at the next one. All right, so you can just look at mine. How did they get X to the 6th from X times X to the 5th? How did they get X to the 6th from X to the 2nd times X to the 4th? What are they doing with these exponents to get that? They're adding them. So even though we're timesing all these factors together, they're telling us how many factors we have of X, right? Or how many factors we have of whatever our base is, because our base might be different than X, right, Jackson? Our base might be 7. Our base might be -2. Our base might be the letter B. Our base can change, but what's important is that when our bases are the same and we're multiplying them, we can add what? What are these things up here called? Do you remember? The exponents. We can add the exponents. So what is our exponent when we just have the base and there's nothing written there? 5 plus what equals 6? 1. So there's a 1 here. We just don't usually write it, right? We just usually have it as just the base. Because 1 factor of it is just that, whatever that is. 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 is 6. Do you see that? All right, let's change to 4. Make a conjecture. So how can I simplify a product of powers with like bases? How did we simplify? What did we do with the powers? We did what with them? We added those exponents. Good. That's it. That's it with addition. And then they give you another set 5. So does your conjecture hold true? Can we add 1 plus 6 to make 7? How about 2 plus 5? 3 plus 4. Does that make 7? So that's how we're going to simplify these things, okay? Does that make sense? So I think just getting to play around with this a little bit shows us what we're learning today. And we've already done this. So go ahead and set your Chromebook aside for a bit. We're going to now look at page 13. Page 13, we just did this explore activity already, but this is page 13 in your text. So turn to page 13. All of second hour should be in this section right here. So that's where it should go back to as well. Be sure we're staying neat. Okay. Where it says learn here. Page 13, page 13, page 13. A monomial is a number. Whew. A monomial is a number, a variable. Remember, that's like a letter, like we just had a base of x. Or a product of a number and one or more variables. For example, 6y squared is a monomial since it is a product of 6 and y squared. The expression x plus 3, notice they are separating the monomials with a plus or a minus. So if you see a plus or a minus in something, it's going to be more than one monomial. So it's not a monomial. It's a polynomial. Polynomial. So x plus 3 is not a monomial since it is a sum of 2 monomials. So we have x as a monomial and 3 is a monomial. But when we separate them with a plus and they're not being multiplied, then we have more than one monomial. So when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. So x is a term, 3 is a term. A monomial only has one term. Mono means one. One. That's mononucleosis. But yes.
It's not a disease too.
Mononucleosis is a virus, I believe.
Yeah, I got the virus.
All right, the expression x plus 3 is the sum of two monomials and therefore not a monomial itself because it has two terms. So we're going to write each expression in the appropriate bin. An example of each type is given. So is x a monomial or not a monomial? It's a monomial. It's just one term. How about 80? Is that one term or more than one term? It's just one. How about x squared minus y squared? Not a monomial. How about 8x? That's just one term, right? I don't see a plus or minus in there.
What is a monomial?
A monomial is one term. One.
Oh.
So it can be a product of things, but it cannot include plus or minus in them. So how about x plus 5? Not a monomial. Good. Polynomial. Love it. All right. Are we good on 13? Any questions about monomials? No, do you have a question?
No,
Just stretching? Okay. Page 14. Product of powers. You don't need to go online, but we can watch what happens here. What's learn? Product of powers is what we want to learn. All right. So there is a nice animation here.
You can simplify the product of powers with the same base.
Same base.
Write 4 squared as a product of factors. Write 4 cubed as a product of factors. There are 5 common factors altogether, so the product is 4 to the 5th power. Notice that the sum of the exponents of the original powers is the exponent in the final product. You can multiply powers with the same base by adding the exponents. The product is x to the 7th power.
Okay. So that's what they're showing you here. 4 squared is 2 factors of 4. 4 cubed is 3 factors of 4 for a total of how many factors of 4? 5. So there are 5 common factors altogether, so the product is 4 to the 5th. All right. We can add the exponents. 2 plus 3 is 5. Notice these both have the same base. So our products have to be the same base in order for us to add them on. So here in words, to multiply powers with the same base, add their exponents. A to the m, so a base to a certain power times that same base to another power is equal to the original base to the sum of those two exponents, okay? So here they showed you 2 to the 4th times 2 to the 3rd is equal to 2 to the 4 plus 3, or 2 to what power? What's 4 plus 3? Careful. 4 plus 3 is 7. So here's our example on page 15. Simplify 5 to the 4th times 5. So 5 to the 4th times 5 to the 1st power. So 5 to the 4 plus 1. What's 4 plus 1?
5.
Good. Or if we put that into our calculator using our nice little caret, we have 5. Remember, the caret is right under your trackpad to the 5th. Excuse me, which is equal to 3,125. So let's simplify this expression. What's our base? What's our base?
4.
Good. Are they both the same? Are they both 4? So we can combine them by adding our exponents.
Okay, so 8.
Okay, so 8. Beautiful. Now I would simply use my calculator to say 4 to the 8th power, which is 65,536. But what is important that we know how to get this right here? This is the important part. Now, when we're looking at it with algebraic terms, we can do the same thing, and they're keeping our base as a letter now. So if we simplified c to the 3rd power times c to the 5th power, we would still add up our exponents. So this is c to what power? 8. And this is as simplified as we could get that because we don't know what c is, right? So let's try this. Tell me, or write down rather, the answer to that check. I want to be sure you know how to simplify x to the 4th times x to the 6th. Try that check. So that's page 15, the bottom of page 15. Try that check.
Okay.
X to what power?
Don't erase that. No. You erase my doctor's phone.
X to what power?
To what power? Don't erase it. What's that one?
So what can you do for that? No, be careful. X to what power? But this is not 1. It's X. No, it doesn't tell us what X is. Guys, we don't know what X or C is here. We can only simplify to this point. So what is our base? X. If our bases are the same and they're being multiplied, what do we do with our exponents? What did we do with our exponents here? We add them. You need to be able to look back at the example. Well, what did I do up here with my exponents? I added them. I'm going to show that work to practice. We learn math by doing math, not just hanging out in class. Unfortunately, diffusion is not going to work for you in this case. Our base is X. What's 4 plus 6? 10. And that is as simplified as we can get it because we don't know what X is. All right. This gets a little bit trickier. First of all, you need to remember what a coefficient is. Does anybody remember what a coefficient is? A coefficient is the number in front of the variable. So -3 is a coefficient and 4 is a coefficient. When we have a number next to a letter, what are we doing with those two things? Multiplying. We're multiplying all of this. So it's still a monomial. I don't see that we're adding or subtracting anything, right? We do have a -3. But we're not adding or subtracting anything. So if we have a monomial, we can simplify it. They're writing these out as factors. What's up? Hurry up. Not sure why that's important right now. Now, when we're multiplying things, it does not matter what order we multiply them in. So they're associating our coefficients together. They're multiplying them together. So negative 3 times 4 is what? Michaela, it's really distracting. What's negative 3 times 4?
12.
Negative 12. Very good.
Negative, no.
Now we're gonna deal with our factors of x. We have 2 factors of x, right? X squared and x to the 5th. So we're going to add our exponents together because they have the same base. So now we have negative 12 is our coefficient, but x to what power? 7. And in case you didn't know, remember our examples, you're using your book for a quiz and you haven't written down the work. Our examples always give the answer and the steps. You just might need to fill in the spots between, okay? So I want you to try this check here on page 16. What did we do first up here? We multiplied the coefficients. So what are the coefficients here? We have a negative 2 and a 3. So if we multiplied the coefficients here, we now need to multiply the coefficients here. So what's our new coefficient? Negative 6. So we know it can't be A or B. Good. Nope. Careful. We have A times A to the 4th. So we have 1 factor of A, and then we have 4 more factors of A. So this is A to the 1 plus 4, which is A to the 5th. So that one was a little bit tricky because our exponent on this A was actually a 1. We just don't always see that 1. So I would make a note that if we have A or any base that's by itself, this is equal to A to the 1st power. If we have, say, the number 72, this is equal to 72 to the 1st power. We just don't write that it's raised to the 1st power. That just means we have 1 factor of that, okay? So it's a little tricky. All right. We're going to save quotient of powers for another day, but as you can see, we're going to follow the same order of exploring and then learning. So we're going to turn to page 23. And we have 4 problems to try. Simplifying the expressions. So these are from the examples that we've learned so far. Right? This is page 23. 1 through 4. All right, try those. I'm going to be around helping. I'm seeing a lot of great things. Some of you are even writing these out, right? 1, 2, 3, 4, 5, 6, 7, 8. Times 1 more tells you have a base of 3 raised to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Or some of you wrote out 3 to the 8 plus 1. I'm seeing lots of great work. So knowing that, some of you are writing out your M's. 1, 2, 3, 4, 5, right? That exponent tells you how many factors of M we have, times 2 more factors of M, for a total of how many factors of M? 7. So I see most of you did this. Some of you used the rule. If we have the same base, we can add the exponents. Okay? So either way. Now 3 and 4 get a little tricky. Right? I would say 3 is the trickiest. But remember, we start with our coefficient. Multiply our coefficient. So we said 3 times 8. Then look at your m's. We have m to the third times m. Then look at your n's. We have n squared times n to the third. So it does get a bit trickier. What is 3 times 8?
3 times 8?
24.
Yeah.
So our new coefficient is 24. That's as simplified as our coefficient gets. What about our factor of m? How many m's do we have? We have 3 here plus another 1. So how many total? 4. So I'm going to write m as my base raised to the 4th power. So this was m to the 3 plus 1. Now how many factors of n do I have? 5. Excellent. Does that make more sense? So hopefully you can do 4, right? Multiply your coefficients. Then figure out how many factors of p you have. So 4 is yours.